If you combine a buried intake pipe with a rooftop downdraft evaporative cooler, you can achieve temperature drops of 30 degrees or more below ambient conditions on hot, dry days. The ancient Persian systems worked partly because thick mud brick walls absorbed heat slowly during the day and released it at night. You can add thermal mass to your modern system by positioning the cooled air outlet so it flows across or through dense materials. Stack concrete blocks or stone pavers along interior walls in the path of the cooled airflow. Fill large clay pots with water and place them in corners of the room. Run your evaporative system during the hottest part of the day when humidity is typically lowest. In most desert climates, this means late morning through late afternoon. At night, in arid climates, open windows on opposite sides of your home to flush accumulated heat and pre-cool your thermal mass for the next day. Your thick walls, concrete floors, and water containers absorb this coolness and release it gradually through the following day. Monitor your evaporative pads or homemade medium for mineral buildup from hard water. Every few weeks, remove the pads and rinse them thoroughly or replace homemade media that has become clogged. Drain and clean your water reservoir monthly to prevent algae growth and mosquito breeding. A complete DIY rooftop downdraft cooler using the materials described above typically costs between $200 and $400. A buried ground coupled intake pipe adds another $300 to $600 if you rent a trencher or dig by hand. Compare this to operating a standard 3-ton central air conditioning system, which costs roughly 30 to 50 cents per hour in electricity. Running that system 8 hours per day through a 4-month cooling season adds approximately $300 to $500 to your annual utility bills, plus maintenance and eventual compressor failure. Before cutting holes in your walls or roof, check local building codes regarding penetrations, structural modifications, and water systems. Many jurisdictions require permits for any modification to your building envelope. Ensure any electrical components are properly rated for outdoor wet locations and connected to ground fault protected circuits. Keep water reservoirs covered to prevent mosquito breeding. You now possess the practical knowledge to build a cooling system that operates on physics rather than on perpetual electricity consumption. The principles are identical to those Persian engineers perfected 3,000 years ago. The materials are available at any hardware store. The industry made this knowledge difficult to find because buildings that cool themselves do not generate monthly revenue. But the physics never changed. Water still absorbs heat when it evaporates. Cool air still sinks. And now you know exactly how to put those principles to work. They buried this knowledge because it threatened their business model. Now you have it. If this changed how you think about buildings, subscribe to Construction Odyssey with Eddie, and please watch the next video appearing on your screen right now.